Okay, everybody, this is a guided walkthrough for the API-based machine from Dockerlabs. Let's go ahead and start with the video. So this is from Dockerlabs, and on Dockerlabs you're able to download Docker containers and then deploy the machines on your local Linux machine and then hack against those machines. It's a very convenient way to do security exercises, and this is how you start. So the first thing you do after you download the Docker container, so for example, we've got API-base. We can click on the download button here, and then we can download it from this mega.nz site. So after the file is downloaded, you'll want to go over to your downloads directory, and you're going to see the API-base.zip file here after it's downloaded. So from there, you can just unzip the file. And there's going to be two files unzipped. There's going to be autodeploy.sh and apibase.tar. So the way we deploy these Docker containers is using the script over here. So in order to do that, we need to make the autodeploy script executable. And then we need to run the autodeploy script with the apibase.tar file. So just run the command here. And it's going to give you a little message in Spanish because Dockerlabs is a Spanish website, so the machines here are going to be in Spanish. But that's just fine because we can translate all of the stuff that we see in the output if we don't speak Spanish. Okay. So after a few seconds, we're going to see that the Docker container is deployed at this IP address. So this IP address is available on our machine on the Docker 0 interface. So the networking interface, our machine is 172.17.0.1, and the Docker machine is 172.17.0.2. So what we're going to do is we're going to start by nmap scanning it. Okay, so when we nmap scan a remote server, we're trying to figure out what open ports are available on the server to see what we can hack against. So we run nmap with -p- to scan all the ports, -t4 to run it very fast but not too fast, and determine we're going to run common scripts and versioning information on whatever services we find with this flag over here. We're going to run it very verbose, which is important, because if we don't run it very verbose, we don't see any output until the end of the scan. And then we have to specify the IP address. So when we run the scan, it's going to tell us almost immediately that there are two ports open on the system. There's port 22, and port 22 is associated with the SSH service. The SSH service is remote login, which is a method through which you can access a computer or a remote server from your local server. And the other port that's open is port 5000. So port 5000 is a little bit unusual, but nmap tells us that it's serving the HTTP website. So HTTP is unencrypted web pages, and we can actually check out what's going on that website by running a very quick web app enumeration tool. So we can run derb, for example. And this is a pretty old tool that can be used to try to determine what endpoints are available on a particular website. So an endpoint is basically a directory or a file. And when we run the tool, it says it couldn't connect. Okay, you know why it couldn't connect? Because we need to specify the port in this case. So the default port for HTTP is port 80, but in this case, we're scanning against port 5000. So we need to add the colon and the port number, which is 5000. Okay, so immediately it starts telling us that there are a couple of directories it was able to find, the add directory and the console directory. So we're actually going to find out in just a second what exactly is going on with this web app. So we're just going to navigate manually to the website using the web browser here. 172.17.02 on port 5000. Okay, so we see some JSON information that's being sent back to us. It says no endpoint selected. Please use /add to add a user or /users to query users. So this is the API base machine. We're talking about web app APIs. So web apps often incorporate APIs as part of their function. So what is an API? API stands for Application Programming Interface, and they allow web apps to interface with each other. And they usually do it through something called API endpoints. So APIs use standard HTTP methods to specified API endpoints to perform different functions, such as creating users, editing user details, deleting users, all this other fun stuff. APIs are ways for web applications to perform certain actions. And APIs, web app APIs often include documentation within the app. And this app's landing page, indicates that there are the following endpoints. So there's the add endpoint and the user's endpoint. Okay, so what we're going to be doing here is we're going to be testing the API endpoints. So we want to test the API endpoints to see how they work. So the add endpoint doesn't use regular GET requests. So if we go over to the website here, and we go over to the add endpoint, which we would use to add users, it says that the method is not allowed. So the method they're referring to is the get method. So that's the regular method for retrieving information from web pages. And what we would need to do is we would need to use Burp Suite to start modifying our requests. Okay, so we would go over to proxy, and then we would start up the web browser for Burp Suite. So inside of Burp Suite, we can open up the Burp Suite web browser, and anything that is sent through the web browser in Burp Suite is going to be recorded by Burp Suite. So we just go back to the web app over here, and then we would go over to the add endpoint. So it says method not allowed, but that's fine. We're going to go over to Burp Suite now. We're going to go to the HTTP history, and then we're going to take a look at the request over here to the add endpoint. So we see here that this is all the information that we sent to the web server. We can modify the request inside of the Burp Suite repeater. So what we would need to do is we would need to click on the add request here. We would right click, and then we would click on send to repeater. And then we would go over to the Burp Suite repeater over here. So in the Burp Suite repeater, we need to modify the request over here. So we know that this method is not allowed, the get method, but we can switch the method from get to the post method. So we can right click and then click on change request method. So this will change it over to a post method. And we can just send something to the server. Let's just send add, I don't know, username. So we're trying to create a user with this endpoint over here. And usually, typically when you add a user to a system, you have to send her a post request to the web application, which includes a username and password. So we have to specify what user we want to add and their password. So username equals something and password equals something. So in their case, we're going to create a user called the Shy Hat, and the password is going to be HackerFrogs. So we're just going to go back to Burp Suite. Username equals the Shy Hat and password equals HackerFrogs. Okay, and after we've edited this, we can just send this request off, and we can take a look at what response came back. So the message says user added, which means, well, I guess that means we added this user successfully. So the next thing we need to do is we need to figure out the other endpoint, because there are two endpoints that are indicated by the landing page. So the other endpoint that we can test is the users endpoint. So /users. The endpoint seems to want a specific URL parameter, which we can fuzz for. So we're just going to go back to the application over here. We can go over to the users endpoint. And it says invalid parameter. So what it's referring to here are URL parameters. So URL parameters are a method where we can send the parameters of our request through a specific URL parameter. I mean, if we were to talking about URL parameters, I can illustrate something real quick over at Google. So if we go over to Google and we were to search for apples, you're going to notice that inside of the endpoint, there's going to be this over here. Hold on. Let's make this nice and big. So there's going to be a question mark, and then there's going to be something, and then it's going to be equal something. In this case, what we're searching for is apples. So we have to send a URL parameter with our search requests to Google to indicate what we're going to be searching for. So we can supply this to the application that we're looking for right now. We're looking at right now, rather. Let me demonstrate how to do that. So if we go over to the web application and we send some sort of URL parameter, for example, test equals who am I, it's going to say invalid parameter. So what we can do is we can fuzz for the parameter. Fuzzing is basically testing all the combinations, and we can do that with a program called FFUF. So this is where we're going to do it. Let me take a look at my notes. Okay, so we're going to use a command that looks kind of like this. Before we run it, let's talk about what the different parts of this command are. Okay, so we run FFUF. We have to specify a URL that we're going to be testing. So this is going to be the application on port 5000. It's going to be the user's endpoint, and we have to specify something that we're going to be testing. So we're just going to do $fuzz, and fuzz, that's going to be replaced by everything inside of a word list. So fuzz equals testing, and we've got a word list that we're going to be using. It's a specialized list of parameter names, and it's called burp parameter names.txt. It's just a bunch of common parameter names that we're going to be testing against. We're going to get all of the responses from the web server, but we're going to filter, well, we're going to try to filter out everything that comes back of a certain size. So if I run it without the filter, then it's going to give us the result of sending all these different payloads over here. But all of the ones that are incorrect are size 35. So we need to filter these out. So we're just going to tack on filter on size 35. After we do that, we're going to see that one parameter comes back, and that parameter is username. So because we did our fuzzing over here, we figured out that username is the name of the parameter that is valid for the application. So we're just going to go back to the application here, and the parameter name is going to be username, and we're just going to try test as the username. Okay, so it just tells us that the user is not found, but there was a user that we successfully added to the system, and that was the shy hat. So if we send that, then we see what I'm assuming is going to be our user ID number, which is number 3. We've got the username, which is the shy hat, and we got the password for this account, which is HackerFrogs. So this is really bad. It tells us that the API is going to expose usernames and passwords if you fuzz it, if you fuzz it successfully. So this is a very big security problem. And let's talk a little bit about this before we fuzz for valid usernames. So we discovered that the parameter that the app is looking for is the username parameter. And because we know that, we can fuzz for valid usernames. Okay, so we're going to be using FFUF to fuzz for the valid usernames. Let's go back. So before we fuzz for the valid usernames, what we're going to do is we're just going to see what this request looks like over in Burp Suite. So in Burp Suite, we're going to go over to, let's see, hold on. We need to record this in the web app first. Okay, so let's see. The endpoint is going to be username equals oh, sorry. So slash users username equals test. Okay, so it says error user not found. That's fine. We're going to test all of the usernames to see which ones are valid. And so over here, we've got the valid request. We're just going to save this. We're going to save this, and we're going to save it as a file to use with the FFUF program. So we're just going to right-click on the request. We're going to click on copy to file. Then we're going to save this as a file. We're going to call it user_request.txt. And then we're going to call it user fuzz. Okay, and then we're going to save this out. And then we're going to go back to our terminal here. Okay, so so this time when we use wfuzz, it's going to be a little bit different. And this is the command we're going to be using over here. So let's talk about what we're doing. So we're going to match all the codes that come back from the web server. We're going to use a request file. So instead of specifying all the stuff that we need to contact the server, we're going to be using a file with all that information inside of it already. So what is inside of the request file over here? Let's take a look. So what we need to do is we need to modify the user fuzz.txt file a little bit. So we're going to do it inside of the text editor here. So this is all of the headers that we need to communicate with the server, but we're going to specify that this is the point that we want to fuzz. So username equals something. We need to figure out what the valid username is. So instead of test, we're just going to specify that this is the fuzzing point by putting in the word fuzz here. Then we're going to save the file, and then we're going to go back and run FFUF. We're going to use a specific user list, and the user list we're using is from the seclist repository. It's a repository of a lot of security-related word lists, and this one's called ZatoNet 10 million usernames.txt. We're just going to test to see which usernames come back. And we also need to figure out what we need to filter on. Whoops, where was it? Okay, because if we send it without a filter, then we're going to get a lot of, well, we're going to figure out that we need to filter it some way, otherwise we're going to get a lot of output. So we see that the size of all of these unsuccessful requests are all size 32. So we're just going to filter on size 32 and then run it again. So this is actually going to take a little while, but I'll tell you, yeah, this is going to take a little while. So we're just going to talk a little bit about what we're doing right now. So we're fuzzing the application. We're trying to figure out which username is valid. And after we figure out the valid username, we're going to try to take a look at their information, because we know that the application tells you the username and password, if you know what the username is. If we go back to the application here, and we put in a valid username, for example, the shy hat, which we created, it tells us the password here. So if we were to find any usernames using the API fuzzing, then we could figure out what their password is, and then that would be a very big score for us, very bad thing for security. Okay, so we got back this username over here, Pingu, and we're going to be checking out this username to see if we can get their password. So through fuzzing, we discover a valid username on the system, and the entry includes the user's password. So this is, while this is an example of APIs knowing way more than, well, revealing way more than they should. So if we go over to the application, and then we go over to username equals Pingu, which is one that we found out. So we see here that there is Pingu your password, and there's also Pingu Pinguinazio. And this is the, this actually turns out to be the password for the SSH login for this user here, Pingu. So I'm just going to copy this. We're going to go over to our terminal. Actually, I think we can shut this off. Okay. And then we're going to log in as the Pingu user to the server here. It's going to ask us for the password. We copied the password, just going to paste it in. And now we're logged in as the Pingu user. Now we have to call in Mr. Scary Hacker Voice Man to talk about how we got in. All right, so I'm just going to call up the Scary Hacker Voice Man and leave it to them.
Hey everybody, it's me, Scary Hacker Voice Man. Scary Hacker Voice Man comes out every time we break into a server, and we just broke into this one. Well, Mr. API-Base Administrator, it seems like your API shares a little bit too much about the users. That is a big mistake. We decided to fuzz the API and find out valid usernames, and then we found out their password. Maybe you knew about these security flaws in your system, or maybe you decided to accept the risk. Well, you accepted the risk. And now we're in.
Okay, so now we are in, and after we break into a server, after we get initial access, what we need to do is we need to escalate our privileges to be not a regular user, but the super user. So the super user on a Linux system is called root. So what we want to do is we want to elevate our access so that when we type in who am I to see what user we are, we're not the Pingu user, but the root user. So the way we elevate our privileges on this system, and the method for privilege escalation is going to be different on every one of these exercises, is inside the home directory, there's a funny file called network.pcap. So PCAP files are, well, they're network packet capture files. So network packets are packets that are sent over a network, and they're all packaged up in this capture file. What we're going to do is we're going to investigate the PCAP file to do our privilege escalation. We're just going to download this file to our local machine, and then we're going to look at it inside of the Wireshark program. So let me see if, okay. So this is the command we're going to be using. The command we're going to be using, it's called scopy or secure copy. And we're going to specify a port number. Well, we don't need to in this case. We're going to specify the username that we're going to access, so the Pingu user, the IP address, and the location of the file, which is home PCAP, home/network PCAP, and we're going to copy it to our current directory. So when we run this, it's going to ask for the Pingu user's password. And let me just copy that again and then paste it in. and then afterwards, we've got the file copied to our local drive, which is the attacker machine. So to open this inside of Wireshark, we could use Wireshark, or we can just use the xdg open command. So xdg open is a Linux command that we can use to open a file with its default program. And for the PCAP files, it's going to be the Wireshark program. Okay, so this is Wireshark. It's a little bit, let me see if I can make this a little bit bigger. Can I increase the size? Yes, I can. Awesome. Okay, so we can increase the size of the interface here. And this PCAP is not super complicated. In fact, there are very few packet captures, which is kind of unusual. Usually packet capture files have hundreds, if not thousands, of packets. In this case, there are only 6. So we can actually go through each one of these manually to see if there's anything suspicious inside of the packets. So we can see the contents of the packet over here in both hexadecimal and ASCII form. And over here we've got login root. So that's kind of suspicious. So login root, the next packet after that is password balulero, which could be an indication that the root password is balulero. It couldn't be that easy, could it? Well, actually it is. So if we go back to, well, let's talk a little bit about this before we finish up. So the privilege escalation for this box is expose credentials in a PCAP file. So there's a PCAP file located in the /home directory. So when downloaded and examined, we see that it contains the credentials for the root user. So I'm not saying that this is an especially unrealistic scenario. People might have sensitive credentials lying around in PCAP files. It is possible. This is why we have to be very careful about what we expose, especially on public directories and not secure directories. But yeah, having your root password exposed in a public directory is not very safe. Okay, so what we're going to do is we're just going to go back to our shell access over here. So we're now the Pingo user. We know that the root password is this over here, balulero. So we're just going to become the root user with the su command. A fun thing is if you run the su command by itself, it automatically tries to log in or to switch users over to the root account. So type in balulero, and now we're the root user. So who am I? We're now root, which means
what are you? I'm system root.
okay, now we're the root user. So we're essentially finished with the exercise. We can move into the root directory, which is the most secure place in a Linux server, and we see that the root directory is empty. So usually in these exercises there would be some sort of flag, some sort of file that we need to access in order to prove that we finished the exercise, but there's none over here. So what we're going to do instead is we're going to wander into the var www directory. There's nothing there. So var, I wonder where the application lives. Okay, but anyways, we've essentially finished the exercise. So let's talk a little bit about what we did in this system before we wrap up. So for this exercise here, it's called ApiBase. We were doing web app API testing. So APIs are application programming interfaces. They're a pretty common part of web applications, and they let the application run a bunch of different functions. For example, getting files, creating new users, deleting users, getting user information, and other stuff like that. So through fuzzing and testing against the API, we were able to discover how the API endpoints work, and then we were able to discover valid username, which included their password. So with that, we were able to log in as that user, and from there we found an exposed We found exposed credentials inside of a PCAP file lying around in a publicly accessible directory. And we use that to become the root user. Okay, so everybody, that was a guided walkthrough for the API base challenge over at the Dockerlabs platform. If you enjoyed this guided walkthrough, please click on the like and subscribe buttons on the video and leave a comment underneath the video. But until next time, HackerFrogs out!
Hey there, HackerFrogs! Are you enjoying this workshop? Learning new concepts and skills? If so, there's a way you can support the channel, and it's totally free. Just click on the subscribe button below the video. Also, click on the like button. And if you have questions or comments on this workshop, please leave them below the video. Thanks for listening. And now, back to our scheduled programming.